Today, friends, we will go through the new subject, soil mechanics. So in the soil mechanics, we will go through the entire definitions that are associated with soil mechanics subject. And in this video, we will mainly focus on the phase diagrams and three-phase system of soil. And we will derive the necessary expressions that are very, very vital in the soil mechanics. So these expressions are the core of the soil mechanics, and if you easily understand and define the different terms related with soil mechanics, then the entire subject will be very, very easier for you. Okay, so if you are new to this channel, please be. So you can like, share, and subscribe to this channel so that you won't miss any new videos and updates. Okay, before starting today's lecture, I want to mention that winners are never afraid of losing. Okay, so the winners are never afraid of losing. So on that note, let us start today's video. So in which now you need to know what is soil mechanics. So soil mechanics is the application of the laws of mechanics and hydraulics for solving the problems related with soil. So this is the branch of that science or that engineering applications related with soil in which you apply the laws of the mechanics and hydraulics for analyzing the parameters associated with the soil. So this is the basic definition of soil mechanics. So soil mechanics, so this soil can be classified on the basis of various purposes. So engineers have their own definitions, and geologists have their own definitions, and agriculturalists have their own definitions. So according to the engineering purpose, soil is defined as the natural aggregate of mineral grains, loose and moderately cohesive, inorganic and organic. So it is the natural aggregate of mineral. So soil is composed of different mineral particles that may be loose or that may be cohesive, that may be organic or inorganic. So this is the simple definition in relation with the engineering purpose. Likewise, according to geologists have their definition in their own language that and say that soil is the disintegrated rock. So rock has been disintegrated into finer forms, forming the soil particles. Okay, so according to geologists, it is a disintegrated rock, and according to the agriculturalist, it is the loose mantle at the surface of the ground that favors the growth of the plant. So agriculturalists define it in terms of the growing capacity of the plant. So it is the surface on the ground that enhance the growth of the plant according to the agriculturalist. So this is the very basic and simple definitions and the way you can classify the soil. The mechanism in which soil is formed, that is the basic phenomenon in which the soil processes takes place for its formation is the weathering. At first, the weathering takes place due to various agencies. The soil or that rock is just disintegrated due to weathering, and then the weathered soil is then transported. Okay, so first weathering, then the weathered soil is transported and then deposited at the certain place, and after deposition the soil is upheaved. So there is certain agencies that changes the to and fro movement of the soil, that is the upheaval. So for the soil forming mechanisms, you have the weathering, transportation, deposition, and the upheaval. WTDU is the basic formation of the soil. Now friends, before moving forward in this three-phase diagram of the soil, we need to know some of the basic terms that you may encounter in soil mechanics. So at first, soil transported by wind. So the soil that is transported by wind is alluvial soil, or the example of the alluvial soil are the loess. Okay, loess are this example. And the soil transported by the running water. So is always your alluvial soil. Soil deposited at the bottom of the lake is the lacustrine soil. And the soil transported by the gravitational force is the colluvial soil, that is also known as talus. And soil found by the glaciers or ice melting, so or the melting of glaciers, are the glacier soil, or also known as the glacial drift. So these terms may be useful for your competitive exams as well. So you must have to remember all these terms. Now friends, we will go through the different properties of the fine-grained soil. So fine-grained soil possesses different properties like plasticity, like thixotrophy, okay, like consolidation and swelling. So these are the various properties of the fine-grained soil. So we will just go in a very short manner what is plasticity. So this plasticity will come in the later lectures, okay, in which we need to determine the plastic limit and the liquid limit by the Otterbach limit or consistency limit. So for a just overview, we are just mentioning all these things. So plasticity is the property of soil by which it undergoes deformation without cracking or fracturing. So it is the property of soil by which the soil undergoes cracking and fracturing, okay, without cracking or fracturing. Okay, so soil just deforms without changing its, or without possessing any sorts of crack or fractures. Okay, so this is the plasticity. And in plasticity we have the two limits, plastic limit and liquid limit. Okay, so plastic limit is that minimum water content at which the soil will just begin to crumble when rolled into a thread approximately 3 mm diameter. So it is the water content, that is the minimum water content. W by C is the water content. Okay, minimum water content at which soil just crumble. Okay, so when you are rolling the soil into a very thin thread like structures, so suppose that may be 3 mm, so it just crumble with the minimum amount of water. So that minimum water content is the plastic limit. Likewise, liquid limit is that minimum water content at which soil is sufficiently fluid to flow in the specified amount. Okay, so it is that water content or the minimum water content in which soil possesses that flowing nature. Okay, so that flowing properties of soil in the specified water content is the liquid limit. Now friends, the second property of the fine-grained soil is the cohesion and Thixotrophy. Okay, so this cohesion is the capacity of the soil for resisting against the shearing stress. So you know that there is very shearing stresses that are occurring in the soil. So for that resistance against the shearing stress, the capacity developed by the soil is the cohesion. Okay, and Thixotrophy is the whenever the sensitive clays are used in construction, they lose strength due to remolding during construction operation. So with the passage of time, strength again increases, though not to the same original level. This strength lose or gain with no change in the volume or water content of the soil is the Thixotrophy. So whenever there is the sensitive clays in the constructions that are happening to remolding during construction, and with the passage of time strength again increases in such a soil, so this strength losing and gaining in the soil with no change in the volume or water content is the thixotrophy. The third property of the fine grained soil is the consolidation and the swelling. Okay, in which there is the one in which volume is reduced, and in the second term swelling, that is volume of the soil is increased. Now friends, we have moved in the three-phase system of soil. So this is the very important topic of soil mechanics, and the basic term that are used in the soil mechanics so are used over the entire syllabus of the soil mechanics. So if you understand and if you carefully understand these terms in the soil mechanics, then the entire soil mechanics chapter will be very subject will be very easier for you. Okay, so the soil, simply representing soil, it consists of the three phases, that is the solid phase, the water phase, and the air phase. Okay, so we have represented in the right hand side as the in the board as the solid phase, okay, and the water phase and the air phase. So in the left hand side there is the volume section, in which the weight of volume of solid is Vs, and the volume of water is Vw, and the volume of air is Va. Okay, and if you sum the volume of air and the volume of water, then you will get the volume of void, Vb. Okay, Vb is the volume of void, and if you add all three volumes, you will get the total volume of soil. Okay, likewise in the right hand side, the weight of solid is represented as Ws, the weight of water is Ww, and the weight of air is Wa. Since the weight of air is very negligible and it can be nearly equals to written as nearly equals to 0, so we have assumed that weight of air Wa equals to 0 in this case. Okay, then the weight of void Wv equals to weight of water plus weight of air. As Wa equals to 0, then weight of void air is equals to the weight of the water, and the weight of solid is represented as Ws. And if you add up all these three weights, that is the weight of void, that is weight of water plus weight of solid, you will obtain the total weight of the soil. Okay, so this is the three-phase system of soil, in which solid, water and air is present. Okay, now we will be focusing on the various relationship between the various parameters that are associated with the soil mechanics. Now we will go through the technical terms that are used in the soil mechanics, so in which we will just discuss about the water content W. So this water content is the amount of water that is present in the certain weight of the solid. Okay, how much water is present in the certain weight of the solid is the water content, that is mathematically denoted by weight of water Ww by the weight of solid Ws into 100%. So if you convert weight of water into the weight of solid, okay, so weight of water is as shown in the phase diagram. Weight of water, it can be written as total weight minus Ws by Ws. So if you solve this, you can get the weight of the water, water content W as W by Ws minus 1 into 100%. In terms of mass, you can write this expression as well. Now friends, we have second is the technical term is the density of soil. Okay, now the soil cannot remain in same position for all the places. In all the places, soil cannot remain in the same condition. So sometimes it may be in the moist condition, sometime maybe in a dry condition, sometime maybe in the solid state, sometime maybe in the saturated condition, sometime it may be submerged condition. Okay, submerged means sometime it may be covered with entirely with the water. Now in such a case, we have different densities. Okay, so the first type of density of the soil is the bulk density or the moist density. It is the ratio denoted by the rho and ratio of total mass of the soil to the total volume of the soil, and its unit is kg per cubic meter. Okay, so the dry density rho d is the mass of solid to the total volume of soil. So mass of solid to the total volume of soil is the dry density, and the density of solid is the rho s. So it is the mass of the solid in the particular volume of solid. So ms by bs is the density of solid rho s, and saturated density rho sat. So this saturated density is the density in the moist condition of soil. Rho sat equals to m saturated mass of the soil divided by the total volume of the soil, and the submerged or buoyant density is rho submerged equals to mass submerged by the total volume of the soil. Here friends, the submerged density can be represented by another formula, rho submerged equals to rho saturated minus rho w, where rho w is here the density of the waters. Okay, so this is the density of water and it is taken as 1000 kg per cubic meter. Now friends, the third technical term that is used frequently in the soil mechanics is the unit weight of soil mass. Okay, so if you replace the density, okay, so if you if you replace the mass, okay, in with weight, so if you replace the mass with weight, then you will get the density that is known as the unit weight. Okay, so in this we have replaced just mass with the weight. Okay, and the density that is obtained is the unit weight of soil. So the unit weight of the soil also have the different terms on the basis of the soil condition. The unit weight of soil have different terms. Now first is the bulk unit weight or moist unit weight gamma. Gamma, that is the weight of soil to the volume of soil. And second is the dry unit weight. Dry unit weight gamma d equals to the weight of solid to the volume of the soil. And the third is the unit weight of solid. So unit weight of the solid is the weight of solid by the weight of volume of the solid. And fourth is the saturated unit weight, and saturated unit weight gamma sat is the ratio of weight of saturated soil to the total volume of the soil. And fifth is the submerged unit weight gamma submerged equals to the weight of the submerged soil to the total volume of the soil. Here the submerged unit weight can be also expressed in terms of the unit weight of saturated soil minus the unit weight of the water. Gamma W is the unit weight of the water. That value is taken as 9.81 kilonewton per cubic meter. Okay, so this is the very, very important technical term that is used in the soil mechanics, and if you understand these technical terms, then you will have very much easier in the reading of the other chapters. The fourth technical term is the specific gravity of the soil solids. So the specific gravity of the soil solid, G, okay, is the ratio of the unit weight of soil solids with the unit weight of the water. So G is the ratio of the unit weight of the soil solid to the unit weight of the water. And if you know the specific gravity of any soil solid, so you can easily find out the unit weight of that soil solid, okay, by just multiplying the specific gravity with the unit weight of water. So unit weight of water is already known as 9.81 kilonewton per cubic meter. Okay, so if you multiply with the specific gravity, then you can easily obtain the unit weight of the soil solids. And the specific gravity of soil solid is the ratio of unit weight of soil solid by the unit weight of the water. Now the fifth technical term that is used in the soil mechanics is the void ratio E. Okay. So this void ratio is the ratio of the volume of void to the volume of solid. It is the how much that is how much the volume of void is present in the volume of the solid. Okay. How much void is present in the solid is the void ratio, isn't it? This is the void ratio represented by E. Okay. And sixth technical term is the porosity eta, that is the ratio of volume of void to the total volume. So I have seen that many of the people or students, they are just confused with the formulas, isn't it? So sometimes we have to use VB, volume of void, sometimes we have to use volume of solid, sometimes we have to use total volume V. So there is always a confusion among students that where to use which formula and all these things like that. So for if you understand, if you remember the void ratio trick, okay, then you will always remember the porosity. So always remember void ratio as volume of void to the volume of solid. For short remembering, you can use the BS Niketan formula. Okay, so B is the void, S is the solid. So in the void ratio, you have volume of void to the volume of solid. Now friends, the seventh technical term is the degree of saturation S. Okay, so this degree of saturation is the ratio of volume of water to the volume of void. So this is the how much amount of water is present in the certain volume of the void. So how much water is present in the volume of the void is the degree of saturation. So always friend, you have to remember that saturation is the word that is always related with water. Okay, isn't it? So in the saturation's formula, always there will be coming the volume of water, isn't it? Because for saturation there need to be a water to be filled in the soil, isn't it? So degree of saturation S is the how much amount of how what or what is the volume of water that is present in the certain volume of void is the degree of saturation, isn't it? And for the fully saturated soil, all void is replaced with the water, isn't it? So for that, if you substitute the volume of void with the volume of water, VW, then you will get the degree of saturation S equals to 1. Likewise, for the dry soil, the degree of saturation will be 0 because volume of water in the dry soil case will be 0, and consequently the volume of consequently the degree of saturation will be 0 for the dry soil. So this may be sometime may ask in your competitive exams. Now friends, the eighth technical term is the percentage air void eta A. So eta A is the ratio of the volume of air to the total volume of soil, isn't it? Into 100% is the percentage air void eta A. Likewise, the next technical term is the air content AC, and this air content is the ratio of the volume of air to the volume of void. So friends, sometimes there may be confusions among these two formulas. So in previous formula, so among these two formulas, we need to remember one formula so that another formula we can remember automatically, isn't it? So if you wish to learn or remember two formulas, then there will be chances that you may be mixed up. So in such a case, you need to remember one formula and relate that known formula with the another formula so that you can easily correlate the difference between them. So we can learn the formula percentage air void eta A. So in percentage air void, it's the ratio of volume of air. So as air is given in the percentage air void, isn't it? So you have to write volume of air, and it is the ratio and divided with the volume of soil. So there is void in the percentage air void eta A. So you have to divide with the volume of void plus volume of solid, that will give the volume of soil. So eta A equals to volume of air to the volume of void into 100%. And in the air content, you have to remember with the, there is the volume of void that will be occurring in the denominator. So friends, we can relate the air content with the degree of saturation, yes. So for that, we know that the volume of void is given as Vb equals to Va plus Vw, and if you solve this, Va will be Vb minus Vw, isn't it? So if you substitute the value of Va as Vb minus Vw, then you can easily obtain air content as 1 minus S. So this is the important expression in which the air content AC is related with the degree of saturation. So whenever you have given the air content, you can easily convert it into the degree of saturation. Okay. Now friends, the final technical term that you have to know is the density index, or the relative density, or the degree of density, ID. So this ID is given by the simple expression ID equals to the void ratio in the loosest state minus the natural void ratio divided by the void ratio in the loosest state minus the void ratio in the densest state. So that can be abbreviated as ID equals to E max minus E divided by E max minus E mean. So this E max is the void ratio in the loosest state. So when the soil is in the loose state, then the void ratio will be more, isn't it? Because when it is in loosest state, then there is more amount of void, then the void ratio will be automatically increased. And E mean is the void ratio in the densest state, and E is the natural void ratio. So this is the void ratio that will be given. And if you know the maximum and minimum void ratio, then you can find the density index of the soil, or relative density, or degree of density, whatever name may be. Its value ranging from the 0 to unity. Now friends, we will be going through the important relationship between the various parameters that we have already stated or already studied previously. Okay, so these relations are very much vital for your soil mechanics course. So first we will be going through the relationship between the void ratio E and the porosity eta. So for determining the relationship between the void ratio and porosity, we need to understand, or we need to know the formula for the void ratio and the porosity. So we know the formula of the void ratio E as the volume of void to the volume of solid. So here we just replace the volume of solid Vs as the total volume minus volume of void, and then we divide the numerator and denominator by the total volume of soil, then we can easily obtain the void ratio E as eta 1 minus eta, that is void ratio equals to porosity 1 minus porosity is the expression and relation between the void ratio and porosity. Likewise friends, we can convert the porosity in terms of the void ratio. So for that we have to know the formula for the porosity eta as eta equals to Vv by V. Okay, so you can replace the total volume of soil as the volume of solid plus the volume of void, and if you divide the numerator and denominator by the volume of solid, then you can easily obtain the porosity eta equals to E divided by 1 plus E. So this is the relation between these two terms. Now friends, the third important relationship between the void ratio, degree of saturation, the water content, and the specific gravity. So this is the very vital relationship between void ratio, degree of saturation, the water content, and the specific gravity. So the derivation of this is that we need to start from the water content. So we know that the water content is the ratio of the weight of water to the weight of the solids. So if you convert the weight in terms of unit weight and the volume, then you will obtain as WW as gamma W into VW, since we know that weight is given as gamma into V. So if you substitute the WW as gamma W into VW divided by gamma, and sorry, WS by gamma S into VS. So here we know that the weight, sorry, unit weight of the water and the gamma unit weight of the solid, it has a specific relation. So we know that the specific gravity is the unit weight of solid divided by the unit weight of the water. So here the relation is been just opposite. So we have gamma W by gamma S as 1 by Z into VW by Vs. So friends, we have obtained relationship between W and Z, and we need to add two more parameters, that is the degree of saturation and the Boyd ratio. And we need to think that how we can achieve the degree of saturation and the Boyd ratio in one expression. So for that we divide the numerator and denominator by whatever figure we are requiring, we just divide it. Okay. So here we know that the degree of saturation is given by the volume of water to the volume of void. So here we need to divide the numerator and denominator by the volume of void VV. So here we divided it with VV, and we can easily obtain the relation between GW and SE. So the final relation is GW equals to SE. So that is specific gravity into water content equals to degree of saturation into Boyd ratio. Now friends, the fourth relationship is the relationship between the dry unit density gamma D, the bulk unit density gamma, and the water content W. So this relationship is also one of the important expression. Now for the derivation of this, we need to know the water content formula as the weight of water to the weight of solid. Okay. So for this derivation, we add 1 on both sides. So adding 1 on both sides of the expression, we get water content plus 1 equals to weight of water divided by weight of solid plus 1. So if you just substitute, then now this weight of water plus weight of solid can be represented as the total weight of the soil, W, capital W. Okay. So water content plus 1 equals to capital W by weight of solid. So this is the expression. So we can just cross multiply and can obtain the weight of solid WS equals to the total weight of the soil, capital W, divided by the water content plus 1. So if we divide both the sides by total volume of the soil V, then we can easily obtain gamma D equals to gamma 1 plus W. Here WS by V, you know that the weight of solid by the total volume of the soil is the unit dry unit density. So friends, we obtain the dry unit density gamma D equals to the bulk unit weight gamma plus 1 plus water content, isn't it? So this dry unit weight gamma D equals to bulk unit weight gamma divided by 1 plus W is the required expression. Now friends, the fifth relationship is between the dry unit weight gamma D, the specific gravity G, and the Boyd ratio E. So we need to derive the expression and relations between them. So for this we know that the unit weight, the unit dry unit weight gamma D is given as the weight of solid by the total volume of the soil. So we just gamma D equals to weight WS can be written as gamma S into Vs divided by total volume. So after that we know that gamma s. So from the specific gravity, we know that gamma s equals to g into gamma w, isn't it? So we just substitute gamma s as g into gamma w into vs by v. Okay. So here now we just replace the total volume of the soil as Vs plus V, isn't it? Vb. So total volume of the soil is the volume of solid plus the volume of void. So we replace volume V as the volume of solid plus volume of void, and then we divide the numerator and denominator by the volume of solid and easily obtain gamma d equals to g gamma w 1 plus E. This is the required expression, that is the relation between the dry unit weight and the specific gravity and the void ratio. Similarly, friends, we can relate this dry unit weight gamma d specific gravity with the porosity. Now we will see about porosity. Likewise, friend, we convert the relationship between the dry unit dense weight, the specific gravity and the porosity eta. So so we start from the dry unit weight gamma d equals to gamma weight of solid by the volume of soil. So substitute similarly from the previous expression, we substitute and easily find gamma d equals to g gamma w 1 minus eta from this solution. Now friends, at 6 important relation is the relation between the saturated unit weight and the specific gravity and the void ratio. So gamma sat G and E relationship we will be deriving now. So for this derivation, we have to know the formula for the saturated unit weight of the soil. So gamma sat is given by W sat by the total volume of the soil. So W sat can be substituted as weight of solid plus weight of void divided by the total volume. Here the weight of void can be written as the weight of water plus weight of air. So weight of air is 0. So we can write WV as weight WW, isn't it? So gamma sat will come out to be WS plus WW by V. So we change the weight into terms of unit weight and volume. So WS plus WW by V will be converted into gamma S into VS plus gamma W into VB by total volume. Here we have just substituted the volume of water as the volume of void, isn't it? Since we have just substituted this. Now if you solve this, we will just receive gamma sat equals to gamma W 1 plus E G plus E. Friends, this is the simple expression, that is the relation between gamma saturated, specific gravity and the void ratio. Likewise, we will be just solving this expression in terms of porosity. Likewise, friend, we can just derive the expression between gamma sat G and the porosity. So for that, we can continue from the previous expression, from gamma sat equals to G gamma W into Vs plus gamma W into Vb by total V. Now in this expression, we just converted everything in terms of porosity. So we just converted the volume of solid Vs as the total volume minus volume of void. And if you solve this, we will just receive gamma sat equals to G gamma W 1 minus eta plus gamma W into eta. So this is the required expression between gamma sat G and the porosity. Now friend, the seventh and the last relationship is between the submerged unit weight gamma sub, the specific gravity and the void ratio. So for that, we know that the submerged unit weight is given as the saturated unit weight minus the unit weight of water. So we previously derived gamma saturated as gamma W1 plus E times G plus E. So this is the formula of saturated unit weight. So if you substitute this saturated unit weight in gamma submerged equals to gamma set minus gamma W, then you can obtain the submerged unit weight as gamma W1 plus E G minus 1 is the required expression. Okay. Now friend, we will list out all the required formula that we have studied and derived till now. Now friend, at last we have just listed out the important formulas that will be very, very essential for you while going through the subsequent chapters of soil mechanics. Now first formula is the relations between the void ratio and the porosity, E equals to eta 1 minus eta. Secondly, the relation between the porosity and the void ratio, eta equals to E1 plus E. Likewise, the relation between the specific gravity, water content, the degree of saturation and void ratio, GW equals to SE. Third, okay, fourth is the relationship between the dry unit density and the unit weight of the soil solid, gamma, that is gamma D equals to gamma 1 plus water content. Likewise, fifth is the relations between dry unit density and the specific gravity G and the void ratio. So gamma D equals to G gamma W1 plus E is the required expression in terms of gamma D, G and E. While converting it into the form of porosity, then we have gamma D equals to G gamma W1 minus eta will be the porosity G and gamma D relationship. Likewise, gamma saturated will be given as gamma W1 plus E times G plus E. And in terms of eta, gamma submerged equals to G gamma W1 minus eta plus gamma W into eta. Likewise, at last we studied the gamma submerged or buoyant unit density, unit weight equals to gamma W1 plus E times G minus 1. So this is the required expressions that we have studied, and this will be very, very useful for you.
So friends, if you find this video as useful, you can like and share to your friends. And for such videos, stay tuned to this channel. Thank you. We will meet soon in another video.